Hey everyone, welcome to the direct comparison test. So the objective today is to use the direct comparison test to determine if an infinite series converges. A couple things that we need to know. This is our definition. The idea here is if we have an expression a sub n, usually the original that we're given, and b sub n, the expression we're going to compare a sub n to, if the sum of b sub n converges and b sub n is the greater function, then the sum of a sub n is also going to converge. The second idea here is that if the sum of b sub n diverges and b sub n is less than a sub n, well then the sum of a sub n is also going to diverge. So this is the big part we're going to use in these examples. The other part you might want to review is our p-series test video, because we're going to be using that example to explain why our b sub n terms converge. So let's look at some examples. Alright, in example 1, does the sum 1 over 1 plus n to the fourth converge, or does that diverge? So I need to figure out what I compare my a sub n with. There's my expression 1 over 1 plus n to the fourth. And the idea here is we're going to be looking at these ideas of benchmark terms, these important terms. So look for your benchmark term. That's going to be the term that has the variable, and probably the variable with the largest power. So my key term here, my benchmark, is n to the fourth. So this is 1 over a number, so I'm going to compare it to 1 over n to the fourth. Now, here's the thing. Notice I already have a sub n being less than b sub n. Well, whatever I pick for n, I can pick any value. This function, this expression on the left, is always going to be smaller because you're going to have one more than that. So for example, 1 and 1. 1 over 1 is 1. If you plug 1 in for n here, you're going to get 1/2. That's smaller. Plug in 2. 2 to the fourth, right? That's going to be 16. Okay, 2 to the fourth is 16. So 1 over 16 plus 1, 1/17 is smaller than 1/16. So a sub n is smaller than b sub n. I've established that. Now, let's look at what b sub n gives us. So, b sub n is 1 over n to the fourth. That's a p-series where p equals 4, so this series converges. So, a sub n is less than or equal to b sub n, and b sub n converges. Therefore, the sum of 1 over 1 plus n to the fourth, a sub n, is also going to converge. Okay, so that's using the direct comparison test. Example 2. Does the sum from 1 to infinity of 1 over n cubed plus n plus 4 converge or diverge? Now, what can we compare our fraction with? 1 over n cubed plus n plus 4. Okay, what can we compare that to? Need a question mark, right? Well, what's my benchmark terms? Well, n cubed and n. N cubed is larger, okay, than n, and it's going to grow faster, so that's going to be my benchmark term. I'm going to ignore n. So I'm going to compare my a sub n, 1 over n cubed plus n plus 4, to 1 over n cubed. Again, larger denominator, so this a sub n is going to be smaller than 1 over n cubed, my b sub n. Okay, so we've established that a sub n is less than or equal to b sub n. Again, if you're unsure, just pick some examples for n, plug them in, and see which fraction is going to be smaller in this case. So 1 over n cubed is a p-series where p equals 3, so this converges. Okay, so once I figure out if a sub n is less than or equal to b sub n or greater than, I look at b sub n and I see, well, what's that series doing? Okay, and I do that. So, because a sub n is less than or equal to b sub n, and the sum of b sub n converges, it's because of the p-series, that means the sum from 1 to infinity of 1 over n cubed plus n plus 4, that's also going to converge. Okay? And finally, does the series 1 over root 2 plus 1 over root 5 plus 1 over root 8 plus ... the general equation is 1 over root 3n minus 1. Does that converge or diverge? So I compare the two. I have 1 over root 3n minus 1. I'm going to compare that to 3n. Okay, that's the dominant term. It's a linear expression. So I can rewrite this 1 over root 3n as 1 over root 3 times n to the 1/2. This gives me a p-series where p is 1/2. That means this series diverges. So this one diverges. And now we know that a sub n is going to be greater than this. So, since a sub n is greater than b sub n, and the sum of b sub n diverges, it follows that a sub n also diverges, so this series is a divergent series. So that's using the direct comparison test to determine if a series converges or diverges. If you have any questions or comments, type them below. See you next time.